Hello. In today's class, we are going to talk about how we create synthetic personal health records using highly realistic data. And I am your host, Jose Lacal. Let's start. Why is there a need for synthetic data? In many industries, there is a need to test and validate early and often without restrictions. You need to test and validate systems and processes. Think of this as running water through pipelines in a new building. The idea is that by using synthetic data, you can flush the entire system, see if there are any leaks, and then you can validate all of your processes and all of your procedures. So synthetic data is very useful to represent customers, processes, products, services, and market conditions. Now, real data would be ideal, but it's not easily available due to privacy regulations in the case of personal information, healthcare info. There are also issues of security. Many times internal data cannot be reused for other purposes than what was originally collected for. And you also need to test what is called corner cases. A corner case, for example, is a male individual that is diagnosed as pregnant. So it's expensive to acquire and safeguard this real data. That's where fake yet realistic synthetic data comes in. The data cannot be totally random. It has to follow some sort of patterns of reality. And that's the data that we generate in this synthetic personal health record. Let me explain. The database structure includes demographic information, medical conditions, devices, drugs, laboratory results, procedures, providers, and vitals. We can also add client-defined tables. All this data, when we talk about scientifically accurate, what this means is that we use open data sources, scientifically accurate information, to generate these synthetic personal health records. For example, we use drug information from the FDA as well as the European Medicines Agency. For conditions and procedures, we use SNOMED, and for laboratory results, we use LOINC, and we use the WHO ATC to provide much more accurate mapping between diseases and treatments and drugs. We have different standard outputs that we're going to show you, and we can also generate HL7 FHIR as well as client-specific formats. Let's start. So the process for building a synthetic PHR is, number one, you need to go to this address, portal.nihpo.com. You can register for free, and then you can generate synthetic PHR with up to 1,000 synthetic subjects per file. So step one is to register for free. You select a username, enter your name and your organization's name and your email address, and select a password. Once you register, you can log in. Once you log in, you can generate a synthetic PHR if you want to create a new one, or you can download a pre-built PHR that you generated previously. To create a new synthetic PHR, you select each country that you want to assign people to, as well as how many individuals in that country. You can have multiple countries with different numbers of individuals in each country. Then you select the gender and the age ranges, meaning what's the distribution between male and female, and the age brackets that you're interested in. Then you select the drug regulator that you want to use. In this case, we have data from the EMA, the FDA, as well as Spain. And you choose the device regulator, and so far we have FDA. And then in terms of the drugs, you can follow two paths. Path one is you allow us to totally randomly assign drugs to the patients, to the synthetic patients, or you can choose the ATC level 1 and level 2, and then we assign drugs based on the ATC class that you chose. Then you select the output options. You can output either JSON or SQLite. SQLite is a portable database file. We can also modify the system to generate client-specific formats based on your needs. And then when you hit submit, it takes a couple of minutes depending on the size of the file, and then you see a window that says your file is ready, you come back to the main synthetic PHR page, and then you can download that file. Okay, so it's a very simple, streamlined process. How many subjects in what countries do you want with what real world data inside? And then once you have the file, let's take a look at that file. The file that we generate is in a format called SQLite. It's a free database, embedded database that's really useful. You can download a free browser at this address, and then you can see what's inside the file. Now, the PHR is structured in 8 tables, as we said: demographics, conditions, devices, drugs, laboratory results, procedures, providers, and vitals. Let's walk through each of these tables. This is the demographic table, where you see realistic but fake names with a user-defined age. You define the specific age range and the gender distribution, and each individual is assigned a real city and town with latitude and longitude. Then we have health conditions using SNOMED, CT, and we also assign the UMLS CUI code for each of these health conditions. Then we assign medical devices to each patient. We assign a prescription drug history with regulatory details, either from the EMA or the FDA. We give them lab results using the LOINC codes as well. And please notice that all of the event dates are within the time frame selected for this study, for this sample of synthetic PHRs. For each individual, we also give them a history of medical procedures using SNOMED CT again, and we also provide the UMLS CUI. Then, if you selected subjects in the US, we give them a provider that they visited using the CMS Medicare provider list. So in a sense, it's like this synthetic person went to this provider on this date, and then there is a SNOMED code for the treatment, and then there's a LOINC code for the lab results. That's the linkage between all these tables. Okay, and then we also give them vital signs. So every time they go to the doctor, there is a checkup, and then these are the vital signs for that person at that point in time. Okay, that's one output format. That's SQLite. Another output format is we can generate what's called HL7 FHIR, which is a different representation of the same synthetic personal health record. We can use all of the required FHIR resources, and what this helps you to do is you can build and test alternative realities. Our data, as you saw, is scientifically accurate, it's very realistic, and then you can use this synthetic data safely, securely, privately. Nobody knows what you're using. Quickly, it's ready to go in a few minutes, inexpensively, repeatedly. Think again about the pipes. You can run the same water multiple times as you modify the pipes, and consistently. This allows you to build reality at scale. You can build alternative scenarios. You build them, run them, evaluate, adjust, rerun. That's the power of the synthetic data that we give you. Contact us if you would like to see a customized sample of our ability to generate synthetic PHR data. Thank you.